So here's the last example from 10.4, and to do this we're going to do the same process that we did on the last one when it was a 2x2, but now we're going to use it as a 3x3. So I'm going to start out by taking my matrix, and I'm going to add to it the identity matrix, and I'm going to solve. Remember, we started out with A times this X equals the B, and what we're going to end up doing is doing the inverse of each of these. Okay, so to find the inverse I have to solve to get the first matrix, this one here, into the identity matrix, and so then the last one will be the inverse. So I'm going to take row 1 and I'm going to switch it with row 2 and switch it with row 1. I don't know why I'm going to do that, but it just made sense to me that I wanted the ones, because we want this position to be a 1, and I already have a 1 there, so I'm just going to switch them. And when I do that, I end up with 3, 2, 6, 1, 0, 0, 2, 2, 5, 0, 0, 1. Alright, so now I'm going to take and I'm going to do row 1 minus three times row 1 minus row 2, and I'm going to put that back in row 2. So I get, that stays the same, and then 3 minus 3 gives me 0. 3 minus 2 gives me 1, and I wanted a 1 there. And then I get through 6 minus 6 gives me 0. 0 minus 1 is negative 1. And 3 minus 0 is 3. And 0 minus 0 is 0. And my bottom row stays the same so far. And I'm going to move up here, and in my move I'm going to take row 3 minus 2 times row 1, and I'm going to put that back in row 3. So my first row stays the same, second row stays the same, and my third row becomes 2 minus 2 row 1, which gives me a 0. That's good. And I get 2 minus 2 gives me another 0. That's good. And I get 5 minus 4 is 1. That's good. And then I get 0 minus 0. 0 minus 2. And 1 minus 0. I get that. And then the last thing to do is get that and that. So if I take row 1, take row 1, let me think about this, minus row 2, and put it in row 1. So 1 minus 0 gives me 1. 1 minus 1 gives me 0. 2 minus 0 gives me 2. 0 minus 1 minus negative 1 gives me 1. 1 minus 3 gives me negative 2. 0 minus 0 is 0. And so 0, 1, 0, negative that position. So I'm going to take row 1 minus row 3 and put it back in row 1. Need a little more room. I think I'm going to have her done. So 1 minus 0 is 1, 0 minus 0 is 0, 2 times row 3, I guess. 2 minus 2 is 0, 1 minus 0 is 1, negative 2 minus negative 2. Minus 2 times negative 2 gives me 4. So I get a 2 there. And 0 minus 2 is negative 2. And the other rows stay the same. 0, 1, 0, negative 1, 3, 0, and 0, 0, 1, 0, negative 2, 1. Alright. Whew. So now I have the identity matrix in the front position. And so my inverse should be this 1, 2, negative 2, negative 1, 3, 0, 0, negative 2, 1. So, if I take, that's my inverse, so I'm going to write it out here the long way. 1, 2, negative 2, negative 1, 3, 0, 0, negative 2, 1, times my original, which was up here. So I'm going to write that so we see it all. So here's my A inverse. Here's my A. And we're going to multiply that by X, Y, and Z. That should be, now we're going to put the inverse here. So our inverse was 1, 2, negative 2, negative 1, 3, 0, 0, negative 2, 1, times our answer matrix, which we basically be that. So I'm going to write that down here, 28, 9, 22. Well, we know that this is going to end up being the identity matrix, because anything times its inverse is going to give us the identity matrix. So we're going to have X, Y, Z times, and when I multiply here, I'm going to have 28 plus 18 minus 44. What is that? 46 minus 44. Minus 44 gives me 2. And then if I go negative 28 plus 27, and my last row gives me 0, negative 18, positive 22 gives me a 4. So we get our X is equal to 2, Y is equal to negative 1, and Z is equal to 4. All right. Let's stop there so we can get to